What's up guys, Shawnthebro here, and today we're going to be going over more hitbox improvements. Now this one's pretty exciting. I actually really enjoyed this one. So hitboxes in games aren't typically handled how we handled them in terms of their active frames. Because we have the proximity, the strike, the throw, and we have projectile hitboxes as well. There's also hitboxes that are on our characters, which we call hurtboxes. In our case, the hurtboxes are active all the time, unless we disable them and they go away, but currently they're active all the time. The hitboxes, however, were visualized for several frames, but they only ever collided on the first frame. So if we missed it on the first frame, we could then not walk into the hitbox and detect collision with it. How we want to handle this is have these hitboxes that are spawned. Anytime they're visualized, they should be able to detect collisions. So we're in our practice mode here. We can see all of our hitboxes. And now you'll see if I am to attack my opponent and walk into the strike hitbox, I still take damage. Now, I don't have walking backward, walking forward to take damage animation. So that is why the animation may look a little silly when I do it. But that is very easily fixable. What's important here is it's not just the first frame. I can walk into the strike hitbox and still take damage. So while it's not a big deal right now, it is important that we have the ability to have hitboxes that are available for multiple frames. This is really useful for a lot of reasons. One reason is just because some attacks, typically stronger attacks, have multiple active frames so that you can hit them at the end of an animation, and then they have a lot more recovery frames. So they're slower, they deal more damage, but you can hit them at any point during that long active window, and then there's a long recovery so they can be punished. Something else that this is really useful for is projectiles. So projectiles have a lot of specific mechanics to them that we've implemented throughout the series. The fireball that I have here is a hitbox and a projectile that can be destroyed. Let's say I am going to do the fireball, and then with the other attack, I go to destroy it. Before in the series, to accomplish this, to actually destroy a projectile with a melee attack, what we would have to do is get the strike hitbox of the defender to occur and overlap with the hitbox on the projectile on the same frame. So you had a few frames of leniency because you could spawn your strike hitbox at any point when the projectile hitbox was close enough. But now, let me show you the difference on this one. So, okay, I was too early, so I can't do it, right? My active hitbox was available through all those frames, and you can see that it canceled the projectile hitbox as soon as they collided. This saved the defender from getting hit by the projectile and also gave them a little bit of leniency so they don't have to be so precise with when they trigger their attack and when it hits the projectile. Most of your attacks are going to be a lot faster than this, but this is just an example. I actually slowed down my light attack for this demonstration and to make it a little bit easier. Anyway, the point is, if I have an attack going and the strike hitbox hits the projectile hitbox at any point, you will be able to destroy it if it's one of those projectiles that can be destroyed. We don't have to worry about getting them to overlap on the exact same frame, which is a big issue that we ran into in the past. Other than that, we can make sure that our system works the same as it had for the other projectile interactions. So just a quick refresher, we can also have two projectiles collide with each other and blow up, assuming they have the same durability or the same amount of hits to destroy each other. We can also have different types of projectiles intersect with each other and actually force a collision where the one projectile destroys the other, if I could perform my own command correctly. So let's try this again. If I do it at the right time, I can destroy the projectile and also go through and hit my opponent. That is still working. And the last case that I can think of for right now is to trigger both of these projectiles and have them collide with each other as well. So all of our logic will be working the way that it was, but it'll be much improved. That's what we'll be covering today. I want to give a huge shout out to my YouTube membership and Patreon supporters before we get started. Thank you guys so much for all that you do, for all the support you've given. I'm so grateful, and this series is so fun to work on, so I can't wait to see what you guys come up with. Before we get started on this episode, if you want to get caught up on the series, this is episode 163 of the Fighting Game Tutorial series, so we have been going for quite a long time, and we still have a really long way to go, but we're making very good progress, and I'm really happy with everything that we've been able to do so far. I'll link this iCard in the top right corner right here to the entire playlist so you can check out everything we've done. If you're just interested in the hitboxes, I will link you to the first episode of hitboxes that we did in the series because we are going to be expanding upon that logic, and so you'll want to watch that one before you watch this one. We can get started in the code today. So if we go to our code and go to our hitboxactor.h, I'm going to scroll down. I'm going to go to my functions. I've added 3 new functions today. I have an activate hitbox, a deactivate hitbox, and a check collision 2. Now, check collision 2 is not going to remain as that name. I just didn't want to rename a function on you that is in the blueprint without showing you where it's coming from, and I want to do that part live. So you can call this whatever you want. For now, don't call it just check collision. We have an event in blueprint that is called check collision, and if you try and do this, you'll get some errors in the blueprint when you build and launch the editor. So call it something else for now. We're going to just basically give it this name, utilize it, replace the blueprint function with it, and then we'll remove the blueprint function, and then we can rename it back to check collision. It's a little bit of a roundabout process, but this does ensure that we're not going to have any errors with the blueprint. Then I've also added a boolean in here called isActive. So quickly going over these, we have activate hitbox, which literally is going to activate the hitbox, meaning it can detect collisions. We have deactivate hitbox, which is going to also deactivate the hitbox, which means it's going to disable collisions. Very simple. Check collision 2. This is what we are going to actually use to check collisions from now on with our hitboxes. Before, we were only doing it in the blueprint. We're going to be doing it in the code now, at least as far as calling this function. I didn't want to switch all the logic over and then also convert it to code in one episode. It's possible we will do our collision checks in code in the future. But for now, the blueprint is still good. The main reason we want to do it in the code is because we want to have control over when we are checking collision. We don't only want to do it on the one frame like we were doing in the past, but now we want to do it while it is active. Note that activate hitbox is blueprint callable, deactivate hitbox is blueprint callable, but check collision 2 is blueprint implementable event, meaning we can call it in the code and fill out the logic for it in the blueprint. Once you have those 3 functions set up, make sure you do grab this boolean. I made it uProperty, edit anywhere, blueprint read write category, hitbox. It just tracks if the hitbox is currently active, so if it is able to detect collisions or not. Now, notice that I have this boolean is active below hitbox data. It is not in the structure for the hitboxes. If you've been following the series, you'll know that we have an fHitbox data structure so that we can make a data table and utilize that to configure all of our values on each hitbox. Is active is not within the structure. This is because is active refers to if this hitbox is active, and it's not something you would ever set to true in the data table. The way I like to think of it is that is active is not a feature that you would configure, right? You wouldn't say, oh, it's active or it's not active to start. Basically, once we spawn it and it's ready, it's going to become active, and then when we're done with it, it's going to become inactive. So we don't need to set it in the data table for someone to configure and to take up more space on our data table. Instead, we just want it as a variable on the class. You can go into your hitboxactor.cpp. In the constructor, we used to set our variables before we moved them over to that structure, in which case we no longer had to. However, since this variable is not in the structure, we do want to set it to a default value, and I'm going to set isActive to be false by default. This is because even when we spawn the hitbox, we don't always want it to activate right away. Sometimes we want to configure some of the properties and change them, such as the rotation, the location, or even the color of it before we spawn it. Now let's go ahead and make our new functions. In this episode, these functions are going to be as simple as they possibly can be. We're just going to set our isActive boolean to be true or false, depending on what it is that we are doing. If it's activating the hitbox, we're setting it to true. If it's deactivating the hitbox, we're setting it to false. There's a lot more we actually can do with this in the future, but for now, this is all we need. If I go back into my hitbox actor, you'll notice that I have overridden tick. I actually had done this in a previous episode, so you may have this, but we never did anything more than just call the super tick function, so the parent's tick. So if for any reason you ignored it, make sure that you do override the tick function in the child class now. But like I said, that was covered in a previous episode. Just want to make sure that no one's leaving that out. Now I'm back in the CPP file, in the tick function, below calling the parents function for tick. What we're going to do is check to see if the hitbox is active, and if it is, we're now going to call our check collision to function. Essentially what this does is say that we want to check collision every frame that the hitbox is active, and that is what we were missing in the hitbox actor BP. Once that is done, we can go into the blueprint. So load your editor, go into your hitbox actor BP. Once you load it up, you may see that you have your check collision function, and for you, it's going to be plugged into this logic here. Now I've changed this logic a bit, and I have some stuff that's ugly because I've intentionally placed it where it was out of the way so that we can move it in. So don't worry too much about what's going on here yet. We're going to cover it all. But just know that you should have your check collision function. This is our main function that we have where all of our hitboxes will check for collision at one point or another. So where your check collision function was, which for me is check collision 2, what you're going to want to do is type check collision 2 and grab this function, and you're going to want to plug this in where check collision was. Okay, so imagine they're both plugged into the same thing right now, check collision and check collision 2. Once you have that done, you can actually disable the link from check collision to all your collision logic. It's not necessary right now. We're going to be using our check collision 2, and so we don't need two functions calling the same thing. Instead, what I did was I used the check collision event to call activate hitbox. Right click, type activate hitbox, and call this. Then plug the original check collision function that was just a custom event we made in the hitbox actor BP into that. And that's what we get here. Check collision is actually called from the spawn hitbox function that we have in the hitbox actor BP. So spawn hitbox does some logic to set the variables needed on this hitbox and then calls check collision. Again, this is stuff we've already covered in the series, so you don't have to worry about it too much. Just know that check collision is called from spawn hitbox. Spawn hitbox is called from our animation blueprint. So I'm going to go into that. And really any of our hitbox functions, our active hitbox, our proximity hitbox, our throw hitbox, or our projectile hitbox will work. If you take a look in here, after we've transferred all of our data from the data table into this hitbox member, we call spawn hitbox, because what we want to do at this point is have the hitbox that we transfer all the data to spawn with that information inside of it, so then we can deal the appropriate damage, have the appropriate stun, all that good stuff. When spawn hitbox is called, remember, check collision is going to be called. But we don't have to call check collision anymore, because now we want to just activate the hitbox at this point. We don't want to check collision for one frame. Remember I said that check collision is just calling activate hitbox now? Why don't we eliminate the middleman? Delete check collision, go into spawn hitbox, instead of calling check collision, call activate hitbox. You can see that worked. I was able to compile without any issues. Now I don't need this activate hitbox call anymore. So now spawn hitbox looks like this, where we grab the hitbox data based on the type it is, we set the appropriate material, basically change its color, set the proper location of the hitbox based on the data we have, determine the visibility based on the game mode. That just means if we're in versus, we don't show it. If we're in training or practice, we do show it. And now we're calling activate hitbox instead of check collision. Now, additionally in this function, there's one other thing we should do. On the projectile hitbox, we were not calling activate hitbox before. We had our own logic for it. But with the changes we're going to cover in today's episode, we can actually make the projectiles and their hitboxes function the same as our other hitboxes, where we were setting the material. We were calling set visibility based off game mode, because we don't need to set the world location the same on projectile hitboxes. That is a little bit different because of the nature of them. They are moving constantly. We call activate hitbox at the end of that. Make sure you do that, because I was not calling check collision at the end of this, so make sure you do add activate hitbox at the end of the projectile path as well. Basically, in spawn hitbox, all of your paths should go to one where activate hitbox is called. Technically, the hurtbox does not require you to do this. The hurtbox doesn't have to be activated. So if you'd like, and what you probably should do for performance reasons, you could add everything that the hurtbox needs, which are these nodes here, and instead of passing it along into the other paths, we can now do this instead. We can still use the location and pass that in here. Something like this. There you go. The hurtbox will now not be always checking for collisions. It doesn't need to, because the hurtbox is going to be checked for collisions, but only when it needs to. Okay, it doesn't need to be constantly checking for it, because the other hitboxes are constantly checking to see if they've collided with it. So we don't need the hurtbox also listening for collisions. Anyway, that's better for performance. It doesn't really hurt anything if you leave it, but I would recommend doing that, because it's always better to have better performance. Now if we go back into our event graph, you'll see that our hitbox should be activated. We no longer have check collision event anymore. So now we want to use our check collision 2 instead. This is going to be done in the code automatically since we did it in tick. However, what we should do is clean this up now. So I'm actually going to close the editor again now that we got rid of check collision. I'm going to go in and I'm going to rename this function from check collision 2 to just check collision. Make sure you also change the function call in tick to just be check collision. And once you're done, go ahead and build it again. It will build successfully, and I'll catch up with you when the editor is back open. The editor is back open, so I'm going to go into my hitbox actor BP again. When you come in, compile might have a red sign here. You can press compile, it should fix it. But most likely it's going to rename your event for you. So you might have to delete your check collision 2 now and just put in check collision one final time. And there you go. Now your function is back in. And it should function perfectly fine. No errors or anything. It was just a little bit confused based on the name change. But now everything should be up to speed. Now let's start going over the real logic that we are changing within the hitbox actor itself to make everything function as it should. So we were grabbing the owner of the hitbox and making sure that it was one of our playable characters. Then we were getting all overlapping actors, and we were using the fighter template character as our class filter here. We are going to need to work with our projectiles to get them to function properly, because the old logic that we had for projectiles was using the onComponentBegin overlap for the hitbox display. Doing that will actually cause some issues with us calling it on tick, and so we're going to need to change our logic a little bit to make sure that check collision can work for both all of our regular hitboxes as well as the projectile hitboxes. Before, we were using get overlapping actors with a class filter of fighter template character, so we were basically just determining if our collisions ever intersected with a fighter template character class. We don't really want to do that at this point because our game is a lot more advanced now. We have projectiles that we can hit. We have potentially objects we can hit and destroy. We may want to be able to destroy walls, boundaries, items, non-playable NPC characters that come in or assists, all sorts of things. So we don't necessarily want to filter the class by fighter template character anymore. I got rid of this one, and basically you don't even have to have two nodes. What you can do is just click your class filter and select none, and it'll say select class. Just showing you that. That is a minor change, but it's going to be really useful for the projectiles in particular for this episode. But it's also just going to be useful in the future. We're not going to be overlapping that many things, so it's not a huge deal if we don't have a filter on there. It's not going to slow us down a lot. But we were looping through all of our overlapping actors and making sure that we weren't colliding with our owner. If we do, we definitely don't want to deal damage to ourselves, so we just ignore that. And assuming we weren't colliding with our owner, we were casting to a fighter template character and doing a bunch of other logic. Above here, I have something else that we'll go over in a second. We're actually going to come back to this after, because this deals with the projectile logic. This is a much needed change for that. Imagine this isn't here currently. We're just going to skip over it for now. Again, I'm going to come back to it in a few minutes. We were casting the object that we were overlapping with to check if it's a fighter template character. Here it's okay to keep this because if it's a fighter template character, and only if it's a fighter template character, do we want to do this logic in front of this. Otherwise, we could use our cast failed to determine what type of character it was and go from there. We were determining if we were using our simple or complex hurt boxes. Both will actually work, but I was only using the simple for the demos. Once a collision has occurred, and we know that it has occurred due to the check complex collision and check simple collision, we can then go into the other functions here. So we have proximity, strike, throw, projectile, hurt box. If the hitbox is any of these types, we'll go on to do whatever logic it is that we need to do in those cases. So collide with proximity hitbox determines if we've actually successfully blocked when backing away. Take damage is pretty obvious, it deals damage to the character. And throw begins the throw on the character. The strike hitbox type and the throw hitbox type are both going to lead to a new function call, which is our deactivate hitbox. Wasn't doing this before because we didn't have it, but now we need to make sure that we can only deal damage one time or throw the opponent one time. This will ensure that after a successful collision with the strike or the throw hitbox, that the hitbox is then disabled and we're no longer checking for collision on it because we only need to check for collision until we find a collision or until the hitbox is destroyed. When I went to compile and play the game, my animation blueprint actually had one issue where we were force calling the check collision function, or really the event in the hitbox actor BP. This is because we had a hitbox that actually was mimicking the behavior we're adding today, where we had this hurricane kick. The character would spin around, and every couple of seconds, it would check collision for it. So every 0.2 seconds, it would determine if collision on that hitbox was available. Now, we actually don't have to do this at all anymore. You could just get rid of it. If you do want to keep it for any reason to look over, go back in your code again, scroll down in hitboxactor.h to your check collision function. And instead of just making it a blueprint implementable event, you're going to want to make it blueprint callable as well. Just separate them with a comma, and you can go ahead and build. Again, once the editor is back open, go back into your animation blueprint. Then go to where your check collision was. For me, it actually automatically fixed itself because it picked up on the check collision event. But if you get rid of the check collision event, drag off of your hitbox reference, or if you have reroute nodes like I do, I'm going to use one of them, type check collision, and it will show up here, and then you can add it back in. So this can still function, although it's not required anymore since our new logic basically does exactly what this was trying to mimic. But it can still function if you have things set up this way that you want to keep. Don't worry, you don't have to get rid of them. That's how you can fix that up and get back to using them. Going back to the logic I mentioned earlier in the episode that we weren't ready to handle yet, now we're ready to handle that. With all that other stuff in place, the only thing we need to worry about now is projectiles. So our projectile hitboxes are handled a little bit differently because by nature they are different. They have a lot more cases than our standard hitboxes for their collisions and what they have to deal with. So we do have to deal with them separately. However, we can actually do it from our check collision function now, whereas before we were using this on component begin overlap. So this logic that I have that's floating here is what we're going to be adding today, and I'm going to make it a little bit cleaner after we actually set it up, but let's just dissect it for a second. So we have our hitbox data, which is our structure with all of our data on it. We use it several times in this class, so you've probably seen it before, but you might have seen it looking like this. Basically, grab your hitbox data variable, drag off of it and type break. We're only going to need our hitbox type for this, so I just went ahead and hid everything else because there are a lot of variables in here. You can click on your break node here and hit hide unconnected pins and just enable the ones that you want. We're going to want hitbox type, like I said. Now we can check and make sure that the hitbox type is projectile, because if it is a projectile, we know that we have to do separate logic. So we can just do a direct equal enum and change the type to projectile. In this case, we just want to do a branch. If it's true that it's a projectile, we're going to do separate logic, but if it's false, we're going to do our standard logic. So we can actually go down here, and this is where the logic is going, so we're going to fit it in here. But if you look at my function, it is immediately after we've determined the hitbox owner, but before we've casted the object to be a fighter template character. We're doing it here so we can simply avoid the cast of the fighter template character. There are lots of things our projectiles can collide with, and we have no reason to assume that it should be a fighter template character right off the bat. We can do that later in the actual projectile logic that we set up in previous episodes. So what I do now is I'm just going to move everything over to fit this in. That right there should do the trick. So now what's going to happen is we are going to make sure that the owner is a fighter template character. We're going to get the overlapping actors, make sure that we're not colliding with the owner. Then we're going to check and see if the hitbox is a projectile or tied to a projectile. And if it is, we're going to do check projectile collision logic. If it's not, we're going to do the cast to the fighter template character and go from there. Do all the standard logic that we've been doing up to this point. Check projectile collision is an event that I added that you won't have yet. So we did have a function called perform projectile collision logic. It's not the same thing. Perform projectile collision logic is really two projectiles colliding and the result of that. So I'm going to rename this function now to perform projectile to projectile collision logic. I know it's really long now, but that's really what it is. That's projectile to projectile collision logic. Whereas we want to have an event to just determine projectile collision in general. Before, we were using our onComponent begin overlap, but now we are going to be replacing that with this new event. So add a custom event, and I called mine check projectile collision. Whatever you call yours, make sure that's what you're calling here. Now, once you have that, the last thing we have to do is actually set up this event. Luckily, all the logic we have in here is going to stay pretty much the exact same. We're going to add 3 things, but all of this logic that you see that is kind of crazy long and there's a lot going on, it's all been covered in the projectile episodes of the series. So if you already watched them, you don't have to do anything. If you have not already watched them and you'd like to, I'll link the first one right here so you can catch up on that. But this we are going to add and link up the same. So let's make sure that we have everything linking up the same way that it was in the past. That's the first step. So the first thing we need to do is disconnect the onComponent begin overlap. So when we came into this function here, and what you'll have now is onComponent begin overlap will be plugged into 2 things. It'll be plugged into a reroute node going above the logic that is used for getting the attached parent actor and casting the default projectile BP, and then calling this function. You also had this node plugged into other component had a section as well, right here. And that was used for casting to the static mesh component to see if we were colliding with a character and what hurtbox we were colliding with. Now what I'm doing is either getting rid of this event entirely or just disconnecting it, doesn't really matter. And instead we're going to replace it with our own logic. Now we want to check our collision on our hitbox display every frame for these projectiles. And so to do that and to make this work the way we want it to, we have to make sure that we can get all the overlapping actors and the overlapping components and use them instead. So I take my hitbox display, which is just my static mesh here. It says blueprint bad right now. It's yelling at me because it can't compile because there's an error. But you'll have a static mesh called hitbox display. You can drag that into the scene and you can type get overlapping actors and get overlapping components. Now, they both return arrays, and you'll see that I have them both here. Hitbox display, get overlapping actors, no class filter. So we can get all the actors we're overlapping with. And I bring this into a for each loop. I was actually bringing it into a for each loop with break, but it's not required. You could do one with break or just a regular for each loop. Basically, drag off overlapping actors, type for each loop, and I'll do it with you live. Bring your new event, check projectile collision, into that. Our loop body is going to go into another for each loop. This one does have to be a for each loop with break. I have a reroute node set up. That's not required. The array element off the for each loop is going to go into where the other actor was. I've temporarily brought back the onComponent begin overlap so you can see what I'm talking about here. Where other actor was plugged in for me and where it might be currently plugged in for you, we're going to use the first for each loop and we're going to use the array element off that and replace what was plugged in from other actor. Okay, so I have a reroute node that's not required. Just basically wherever other actor was going, plug this array element into that. Notice, onComponent begin overlap, other actor, this is the actor that it was overlapping with. We're getting the overlapping actors of the hitbox display, and we're just passing that in. So we're just changing. We're not using this event to do it. We're getting that data on our own. I also have one other thing here. On completed of this event, we want to call safely delete hitboxes, because what this is going to do is clean up our hitboxes after we're done looping through them. That's super important. We don't want to delete things we're looping through. You can't delete something you're iterating through. It will throw the loop off, can cause you to crash or get very bad data very easily. We'll go over safely delete hitboxes in a second, but I would recommend you make the event now and plug it into completed so you don't forget. So another add custom event and call it whatever. Again, I called mine safely delete hitboxes. It's down here. Just make it so that you can call it. We'll go over the logic. And we're going to go from completed into safely delete hitboxes. Notice that that does not go into anything else. That's all it does. But the loop body does go into another for each loop. And this one has to have a break, for each loop with break. So now hitbox display get overlapping components. That's the other node I was showing you. That also returns an array. We need to check out the components we're overlapping with, because when we collide with our fighter template character, then they have multiple hurt boxes, and we need to know what type of collisions are acceptable. Sometimes you can only hit against high hitboxes or low hitboxes, and it's really important that we overlap with the right one. So we do need to check our components that we're overlapping with. We can do for each loop with break. The array will go in there. The loop body is going to go into a branch that checks our Boolean is active. That's the one we created earlier in the episode. So just get that, drag off of it, put that into a branch. Now, if it's false that the hitbox is active, we just basically want to end this. We don't want to go any farther. So if it's false, you can go into the break. I've just added some reroute nodes so it's a little bit cleaner, but false, if it's not active, we don't want to continue. We don't want to go through any further logic. You could actually go one step further, break out of this, and then on loop body, and check if the hitbox was active here, and then break out of this loop as well. However, they'll fail out pretty quickly. Anyway, if it's true that the hitbox is active, we can then go into the first node that our begin overlap was going into. So where the exec node was going into, just replace that with the true. Then, where the other component on the onComponent begin overlap was going into, just replace that with the array element from the second for loop. At that point, we've fully transferred over the logic to this new event, and we don't need the onComponent begin overlap anymore. If you want to keep it in here for any reason, feel free to, but you can delete it. It's safe to do. I'm going to just clean this up a little bit and put it into position. It's not super ugly right now, but it definitely could be better. So I'm going to bring it over here. So basically, onComponent begin overlap has now been overwritten by check projectile collision. I'm going to go ahead and remove this because, like I said, we don't need it anymore. Now there's just a few things we need to add to this event, but they're a lot easier than what we just did, so don't worry. The next thing we want to do is set up safely delete hitboxes. So the reason I have this safely delete hitboxes function is because projectiles can collide with each other and they can destroy hitboxes. In our old logic, it was working because two projectiles would detect that they were overlapping with each other and they would destroy each other. We handled both cases. But now we're checking on tick for collisions, and it can be a little bit different because even though tick technically does run for all the actors we've chosen every frame, they don't necessarily line up. So one projectile could collide with another one, and only one of the projectiles would be destroyed, even if they were both supposed to, meaning that one character would get an advantage over the other based off of just a tick condition where one fired before the other. So let's go to our safely delete hitboxes and let's set this up. I made a variable that is a hitbox actor BP array, and I know it's weird again because we ourselves are hitbox actor BP, but I made an array of hitbox actors that it has nothing in it, and we loop through it and we only destroy them once this array is done. If we don't do that, again, we could delete the wrong actor, we could delete it while we're looping through it, it could cause errors, a crash. It's just a lot safer to do it this way than to just destroy them outright, and it will solve some bugs in the future as well. So I went ahead and made a variable, and I called it hitboxes to destroy. Then I changed the type to be my hitbox actor. I just made it the code class, but you could make it the blueprint class as well. It doesn't really matter in this case because we're just tracking it to destroy it. Once you choose this, choose object reference. And then you can click on the variable, go to the details panel. Right next to the variable type, you can then click on the button that'll look kind of like a pill or like a capsule, and you'll change it to the 3x3 of squares, which is the array. So then you have an array of hitbox actors. Now we can set up safely delete hitboxes. Essentially, we're just going to clean up this array. It's actually very simple. Even though we haven't added anything to it yet, this should make sense because we're basically just taking whatever we add to this array, destroying all the elements in it, and then clearing it out in case there's any leftover data. So I grab my hitboxes to destroy, drag off of it, and get the length. And this is how many elements are in this array. Now this is a real number of elements in the array. So if there's index 0 through index 4, there's actually 5 elements in the array. 0, 1, 2, 3, 4. That's 5 elements. Because length returns the actual number of elements, we can't access index 5. We can access index 0 through 4. So we have to subtract 1. Integer minus integer. Then we want to do a standard for loop, not a for each loop. We just want to do a standard for loop with this index. And we want to pass the result of the subtraction into the last index. Leave first index at 0. Now, off of hitboxes to destroy, type get, and we want to get a copy, and we're going to pass in the for loop index into the index required on the get node. So basically, retrieve the element in this array at this location. Then we want to drag off of that and destroy it. Since we are completed the for each loop, and that's where we're calling this function, we know it's safe to remove these hitboxes now because we're not currently iterating through them. So you can destroy it now. Once this loop is completed, it means everything in this has been destroyed, and really, there shouldn't be anything in here. I like to do a safeguard and just clear it, but it's actually not required. I just like to clear it because I think it makes sense. We want to make sure there's nothing in here if anything got left over. Now the last thing we need to do is figure out what we want to add to this array. We can go back to our check projectile collision, and we want to scroll over, and we want to get to a point where we have some different branching paths here. You may have a section where you're checking your component for a static mesh component, and you're checking to see if it has component tags, such as HB for hurtbox. And that's how we know that we're attacking a character. Alternatively, if it doesn't have that, you want to see if we're colliding with a hitbox actor, because potentially, if this object is one that can be destroyed by a strike hitbox, maybe the character meleeed the attack, in which case we have to be careful and make sure that we destroy the projectile, not damage the character. Once we're at this crossroads, we're in the right area. For the one where the character is performing a strike hitbox that collides with this projectile hitbox, we want to scroll over a little bit, and we should see a cast to default projectile BP, where we check to see if it can be destroyed by melee. If it can, we decrease the durability on the projectile. Then we check to see if that was enough to destroy the projectile. If it was, we see if we should display the hit effect. Regardless of the outcome of that, we were destroying the projectile BP. However, the hitbox BP was being destroyed after that, and we were making sure that the actor wasn't already being destroyed. However, now that we're iterating through a for loop to determine what actors we're overlapping with, if we try and destroy actor here, we'll almost definitely get errors. To put it simply, the actor we're trying to destroy is one that is within the loop that we're iterating through, and at one point or another we're going to run into that actor, and if he's already destroyed, we're going to get an error. So instead of calling destroy actor, okay, the false is where we were calling destroy actor. Instead of doing that, I'm now calling deactivate hitbox. We know that we're now at a point where the hitbox has been collided with and its duty has been fulfilled. So we want to deactivate it to disable it from going into more collisions, and then we want to add it to the hitboxes to destroy array so that we can clean it up safely when the time comes. So I'm removing the destroy actor that we had. Instead, I'm calling deactivate hitbox, and then I'm taking my hitboxes to destroy, typing add unique so that we can only have one instance of this hitbox in the array. Then for the element we're adding, this is the self. Get a reference to self. This is saying us, the hitbox we are, should be added to this array, and we want to destroy it only when we go into the safely delete hitboxes function. And that's how you get this right here. Now you can copy this if you want, because we are going to use it again. Let's go back to the crossroads we were at earlier, where we were checking to see if we collide with a fighter template character or a hitbox actor BP. Let's now check and see if we've collided with a character. If we have, we make sure that the projectile does not belong to the owner. Technically, this is actually outdated as it's not required because of this new logic. We are making sure that we're not the owner, but we've already had a lot of changes in this episode, so I'm just going to leave it for now. Then we do the logic for if a character has collided with a projectile hitbox, then we call take damage on the character. At this point, I'm going to deactivate the hitbox immediately. This is because, remember, we're dealing with projectile hitboxes here. As soon as the damage has been dealt, we want to deactivate it. If we don't deactivate it, the projectile can keep moving and keep damaging the opponent. In fact, it can kill them very easily in a matter of seconds if that hitbox is not deactivated. It's important to do it immediately after take damage, because if something like the get attached parent actor fails and is not valid, then it will never hit deactivate hitbox. Say the projectile was destroyed before the hitbox, could be due to a race condition or some of our logic, then the hitbox won't be deactivated. So I deactivate it immediately after take damage. Note that deactivate is not destroy, they're not the same thing, it's just not checking for collision anymore. We don't want to destroy it just yet because we do have some other logic where we use it, like we use it to get the parent actor, get the projectile, get details about the projectile, like if we should display the hit effect, and if it can even be destroyed upon collision. Once all that stuff is settled, we go to an area where we check to see if the actor is being destroyed, and again we're checking self, so we're checking to see if this hitbox is already being destroyed. If it was false, we were calling destroy actor, but no more. We're going to do what we just did up above in the other state, which is where we take our hitboxes to destroy, we add unique self to it, so it will be destroyed safely when the time comes, not right here where we could get an error for looping through and destroying it at the same time. Now we're done with our massive logic here. That is our check projectile collision function. The last thing we need to do is go into our perform projectile to projectile collision logic. This is the one we renamed earlier in the episode. This is what happens if two projectiles collide with each other. All of the logic is the same except the last logic. So essentially we go through, we see if the projectile we collide with still exists. It hasn't been destroyed yet. If it hasn't, we deal damage to it, we decrease its durability, then we decrease our own durability. Make sure that everyone is accounted for, all the damage is accounted for. At the very end of our logic, if this projectile was going to be destroyed based on the collision between the two projectiles, we of course destroy the projectile, but then we also go to clean up the hitbox. This is the same condition as before. We can't destroy the hitbox if we're in the hitbox and looping through the actors we're overlapping with. So one final time, instead of calling destroy actor on false, we are going to take the hitboxes to destroy, add unique, and add self to it. At this point, everything will have been transferred over to this new system of hitboxes, and additionally, you will be able to damage opponents on any part of your strike hitbox. So we can use our proximity hitboxes and block at any point during the attack. If I am to back away from the opponent, it will pick up on it immediately now, not just if I am blocking or backing away during the first frame. Same goes for projectile attacks. So if I'm backing away, at any point during the collision, I will go into the block. Strike attacks are the same. If I walk into them at any point while the strike hitbox is active, I will take damage. And then, of course, all the projectile cases that I showed throughout this episode will now be active and working. So anyway, guys, I hope you enjoyed this episode of how to upgrade your hitboxes significantly. We have a lot of logic being done here, and we have a lot of advancements made to the series. With all that said, if you did enjoy this episode, please subscribe. It does more for myself in the series than anything else you can do, and I just really appreciate it. I want to give another shout out to my YouTube membership and Patreon supporters. Thank you guys for all you do. Hope you're enjoying the series, and very, very excited to see what you come up with in your projects. If you had any issues with this tutorial or any of my tutorials, feel free to join the Discord community. It's completely free, and I'd be happy to help you out. Like I said, guys, that's all I got, so thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.